So the question would be, what is data structure? And you'll find that data structure refers to the way that data is organized and is manipulated, and it seeks to find ways that make data access more efficient. And when dealing with data structures, we not only focus on one piece of data, but we focus on rather different sets of data and how they can relate with one another in an organized manner. And if we try to differentiate file structure from storage structure, we'll find basically that the key difference is that the memory area that is being accessed is the key difference. And so when dealing with the structure that resides within the main memory of the computer system, this is referred to as storage structure. And when you're dealing with an auxiliary structure, we refer to it as file structures. So when is a binary search actually best applied? You find that a binary search is an algorithm that is best applied to search a list when the elements are already in order or sorted. And the list is search, and it starts in the middle such that the middle value is not the search key, and it will check to see if it will continue the search on the lower half of the list or the higher half. And the split in search will then continue in the same manner. Another thing is, what is a linked list? Well, a linked list is a sequence of nodes in which each node is connected to the next node that is following it, and this forms a chain-like link data storage. And you could ask, how do you reference the elements in a one-dimensional array? You'll find that you'll use an index loop, and their counter runs from 0 to the array size -1. And in this manner, we'll be able to reference all the elements and sequence by using the loop counter as the array subscript. So in what areas do data structures actually apply? Data structure is actually important in every aspect where data is involved. And in general, algorithms that involve efficient data structures is applied in the following areas. You'll find in numerical analysis, operating systems, AI, compiler design, database management, graphics, and statistic analysis, just to name a few. And you could be wondering, what is LIFO, L-I-F-O? Well, LIFO is short for last in, first out, and it refers to how data is accessed, how it's stored, and how it's retrieved. And using this scheme, data that was stored last should be the one that is extracted first. And this also means that in order to gain access to the first data, all the other data that was stored before this first data must first be retrieved and extracted. And so what is a queue? Well, a queue is a data structure that can simulate a list or stream of data. And in this structure, new elements are inserted at one end of existing elements and removed from the other end. And you could be wondering, what are binary trees? And a binary tree is one type of data structure that has two nodes, a left node and a right node. And in programming, binary trees are actually an extension of the linked list structures. So which data structures is applied when dealing with a recursive function? Well, recursion, which is basically a function that calls itself based on a terminating condition, makes use of what's known as the stack. Using LIFO, a call to the recursive function saves the return address so that it knows how to return to the calling function after the call actually terminates. So what's a stack? Well, a stack is a data structure in which only the top element can be accessed. And as data is stored in the stack, each data is then pushed downward, and that leaves the most recently added data on top. And if we would explain what is a binary search tree, well, that stores data in such a way that they can be retrieved very efficiently. And the left subtree contains nodes whose keys are actually less than the node's key value, while the right subtree contains keys that are actually greater than or equal to the node's value. And both subtrees are actually binary subtrees. So what are multidimensional arrays? Well, multidimensional arrays make use of multiple indexes to store data, and this is useful when storing data that cannot be represented using a single dimensional indexing, such as data representation in a board game, tables with data that is stored in more than one column. And then is a linked list considered linear or non-linear in the data structure, and this would depend on where you intend to acquire the linked list. And if you base it on storage, a linked list is then considered non-linear. And on the other hand, if you base it on access strategies, then the linked list would be linear in that case. And so when it comes to dynamic memory allocation, how does that come to manage? How does it help in managing data? You'll find beside being able to store simple data types, dynamic memory allocation can combine separately allocated structure blocks to form composite structures that expand and contract as needed. And what would be FIFO? Well, it's first in and first out, and it's actually used to represent how data is actually accessed in a queue. And data has been inserted into the queue list, the longest, and it's the one that's removed first. And so what is an ordered list? And an ordered list is a listing in which each node position is then determined by the value of its key component, so that the key values form an increasing sequence as the list is being traversed. And what is merge sort? Well, merge sort takes a divide and conquer approach to sorting data. And in a sequence of data, adjacent ones are merged and sorted to create bigger sorted lists. And these sorted lists are then merged again to form an even bigger sorted list, which continuously continues until it has one single sorted list. And if we differentiate null and void, well, null is actually a value, whereas void is actually a data type identifier. And it's a variable that, well, if a variable is given a null value, it simply indicates an empty value, and void is a kind of pointer which is having actually having no initial size. And what is the primary advantage of the linked list? Well, a linked list is a very ideal data structure because it can be modified easily, and this means that modifying a linked list works regardless of any number of elements in the list. Yeah, so what's the difference between a push and a pop? Well, pushing and popping applies to the way data is stored and retrieved within a stack. And a push denotes data being added to it, meaning that the data is being pushed into the stack. And on the other hand, a pop denotes data that's being retrieved, and in particular it retrieves to the topmost data that's being accessed. And then what's a linear search? Well, a linear search refers to target keys being searched in a sequential data structure. And using this method, each element that is in the list is checked and compared against the target key, and it's repeated until found or until the end of the list has actually been reached. And how does variable declaration affect memory allocation? Well, the amount of memory to be allocated or reserved would depend on the data type of the variable that's actually being declared. So, for example, if a variable is declared to be an integer type, then 32 bits of memory storage will be reserved for that variable. And so what's the advantage between a heap over a stack? And basically the heap is actually more flexible than the stack, and that's because memory space for the heap can be dynamically allocated and deallocated as needed. And memory in the heap can also be slow when compared to that of the stack. And so what is a postfix expression? Well, a postfix expression is an expression in which each operation follows its operands. And the advantage of this form is that there's no need to group sub-expressions in parentheses or to consider the operator's precedence. So what is data abstraction? Well, data abstraction is a powerful tool for breaking down complex data problems into manageable chunks. And this is applied by initially specifying the data objects involved in the operations to be performed on these data objects without being overly concerned with how the data objects will be represented and stored in memory. And how do you insert a new item in a binary search tree? Well, then assuming that the data to be inserted is a unique value and that is not an existing entry in the tree, well, we have to check if the tree is empty. If the tree is empty, and if it's empty, you just insert the new item in the root node. And if it's not empty, you refer to the new item's key. And if it's smaller than the root's key, you insert it into the root's left subtree. Otherwise, you insert it into the root's right subtree. So how does a selection sort work for an array? Well, a selection sort is a fairly intuitive sorting algorithm, though it's not necessarily efficient. To perform this, the smallest element is first located and switched with the element at subscript 0, and thereby placing the smallest element in the first position, and the smallest element remaining in the subarrays is then located next to the subscript 1 through n1 and switched with its element at subscript 1, thereby placing the second smallest element in the second position, and the steps are repeated in the same manner till the last element. So how do signed and unsigned numbers affect memory? Well, in the case of signed numbers, the first bit is actually used to indicate whether it's positive or negative, which leaves you with one bit short. And with unsigned numbers, you have all bits available of that particular number, and the effect is then best seen in the number range of unsigned 8-bit numbers, which has the range of 0 to 255, while an 8-bit signed number has a range of 128 to plus 127. So minus 128 to plus 128. And then what's the minimum number of nodes that a binary tree can have? You'll find a binary tree can have a minimum of 0 nodes, which occur when the nodes have null values, and the binary tree can have 1 or 2 nodes. And when we're talking about dynamic data structures, these are structures that expand and contract as the program runs, and it provides a flexible means of manipulating data because it can adjust according to the size of the data. So in what data structures are pointers applied? Well, pointers that are used in linked list in various applications in data structure, you'll find data structure that makes use of this concept include the stack, queue, linked list, and the binary tree. And do all declaration statements result in a fixed reservation in memory? Well, you'll find most declarations do, with the exception of pointers. And pointer declaration does not allocate memory to data, but for the address of the pointer variable. An actual memory allocation for the data comes during the runtime. And a cool question is, what are arrays? Well, when dealing with arrays, data is stored and retrieved using an index that actually refers to the element number in the data sequence. And this means that data can be accessed in any order. And in programming, an array is declared as a variable having a number of indexed elements. So what's the minimum number of queues that are needed when implementing a priority queue? Well, the minimum number in this case would be 2, because one queue is intended for sorting priorities, while the other queue is intended for actual storage of data. And then which sorting algorithm is actually considered the fastest? Well, there are many types of sorting algorithms: quick sort, bubble sort, balloon sort, radix sort, merge sort, and there's all different types, and not one can actually be considered the fastest because each algorithm is actually designed for a particular structure and data set, and it would really depend on the data set that you'd want to sort. And how can we differentiate a stack from an array? So data that is stored within a stack follows the LIFO pattern, and that means that the data access follows a sequence wherein the last data to be stored will be the first one to be extracted, and arrays, on the other hand, does not follow a particular order and instead can be accessed by referring to the indexed element within the array. So we give a basic algorithm for searching a binary search tree. Well, if the tree is empty, then the target is not in the tree. End search, if the tree is not empty, the target is in the tree, and if the target is not in the root item, you check if the target is smaller than the root's value, and if the target is smaller than the root's value, you search the left subtree, else you search the right subtree in that order. And what's a dequeue? Well, a dequeue is a double-ended queue, and this is a structure wherein elements can be inserted or removed from either end. And what is a bubble sort, and how do you perform it? Well, a bubble sort is one sorting technique that can be applied to data structures like an array, and it works by comparing adjacent elements and exchanges their values, especially if they're out of order. And this method lets the smaller values bubble to the top of the list while the larger value sinks to the bottom. So what are the parts of the linked list? Well, a linked list typically has two parts, the head and the tail. And between the head and the tail lie the actual nodes, with each node being linked in a sequential manner. And so how does selection sort work? Well, selection sort works by picking the smallest number and placing it in front. And this process is then repeated for the second position towards the end of the list. And it's the simplest sort algorithm. And what's a graph? Well, a graph is one type of data structure that contains a set of order pairs. And these order pairs are also referred to as edges or arcs, and they're used to connect nodes where data can be stored and retrieved. So how can we differentiate linear from non-linear data structure? Well, the linear data structure is where data are actually adjacent to each other. And examples of linear data structure include arrays, linked lists, stacks, as well as queues. And on the other hand, the non-linear data structure is a structure wherein each data element can connect to two adjacent data elements. And the examples of non-linear data structure include things like trees and graphs. So what's an AVL tree? An AVL tree is a type of binary search, a binary search tree that is always in a state of partially balanced. The balance is measured as a difference between the height of the subtree from the root. And this self-balancing tree is known to be the first data structure to actually be designed. So what are doubly linked lists? Well, these are special ones wherein traversal across the data elements can be done in both directions. And this is made possible by having two links in every node, one that links to the next node and another one that links to the previous node. And what's Huffman's algorithm? Well, Huffman's algorithm is associated in creating extended binary trees that has minimum weighted parts lengths from the minimum given weights, and it makes use of the table that contains the frequency of occurrence for each data element. So what is Fibonacci search? Well, Fibonacci search is a search algorithm that applies to a sorted array, and it makes use of a divide and conquer approach that can greatly reduce the time needed in order to reach the target element. So let's briefly explain recursive algorithms, because this targets the problem by dividing it into smaller manageable subproblems. And the output of one recursion after processing one subproblem becomes the input to the next recursive process. That's basically what it is. How do you search for a target key in a linked list? Well, to find a target key in a linked list, you have to apply sequential search, and each node is then traversed and compared with the target key, and if it's different, then it follows the link to the next node. And this traversal continues until either the target key is found or if the last node is actually reached. And that's it for now. Thank you for listening to this session about data structures, and I hope it can help you in one way or the other. Just listen to it and find the particular areas you are interested in. My name is Ian Hillman, reporting for storeandholds.com.